Hi, and welcome to the third video in the series of 4 videos describing project options in our class. If you recall, the first video talks about where the data came from, their weather data that I collected, and I explained how that works. In the second video, I showed a short P5JS sketch that showed loading that CSV file into memory, into a table in P5JS, and iterating through it to get the values out. In this video, I'll show you a starter sketch for the graphing program. This is the program that draws a scrolling graph, meaning rather than one chart that shows the entire data series, which would be very, very long because there's 147,000 points in the CSV file, I'm going to make a graph and have you make a graph that shows a subset of that, maybe 400 points, and scrolls it over time. So you can actually see the temperature change as the program runs in speeded up real time. So we'll take a look at the sketch to do that and we'll walk through it. This assumes that you saw the second video as well, because I'm not going to go into a lot of detail about the loading of the file or the structure of the file. I'm just going to start right out with this particular sketch. So let me share my screen and I'll show you the sketch that we need. Okay, what you should see now is a window that shows you the P5JS editor. And we looked at that in the second video. And I'm going to walk through the program. This program is more complicated, obviously, than the program that just loaded the data, because this program loads the data and then it also draws a graph of one element of the data. But that's you get that as a part of the sketch. I'm going to ask you to make some modifications and enhancements to this to add more data, add more graphics, and make things more impressive. So that's, and you'll see here, we'll go back to this list, a list of some ideas you can do. But let's go through the sketch first. Remembering the variables on lines 21 through 24 are basically global variables. So they're accessible throughout the program, whether you're talking about the preload method or the setup method or the draw method. And WX table is a table that's going to hold the values from the CSV file. Sample num is what row you're on. Max row is the maximum number of rows that we read in from the CSV file. And temp DS, you'll see in a minute, becomes the an object essentially that lets you use some of the code I provide to actually draw the graph. Okay, the so preload we talked about in the previous video. I won't go back over that. Setup is straightforward. Again, this time you probably, since we are using a graphical output, you probably will want to change the size of the canvas to something more suitable. That depends largely on how much screen real estate you have to work with on your computer. Setting up a color. If you have more than one data stream on the graph, probably need to give them each a different color or somehow make them each visually distinctive so you can tell one from another. So I'm just picking green for the temperature data stream. Line 52 is new with this sketch, and this is basically object-oriented programming in JavaScript. What this does, there's a class called DataStream. We'll look at that in a moment. It's available over on the left-hand side. It's available right here. And that contains the data necessary to draw one section of the graph and scroll it. So to get that started, we have to instantiate it. We have to make an object of that type. And we're going to tell it that it contains temperature. And we're going to say how wide it is, which will be automatically the width of the canvas. That'll be convenient. And what color to make the series. That's all setup has to do. Draw, of course, is where, as before, this is where most of the work of the program is done. The sample num plus equals 5, the skipping samples, that's exactly like what we talked about in the second video. Just speeds things up. The conversion from Fahrenheit, from Celsius to Fahrenheit, we did before. What's new is line 69. Because the values in Fahrenheit temperature in my yard are going to range between about, maybe 30 and 90, during this period of time, that doesn't make a very impressive graph if the window is 400 pixels tall. So we're using a map function in P5JS to stretch the range of values, Fahrenheit temperature values, between 30 and 90 into a range between 0 and 400. So that's going to make the graph big enough to see. If you want to know how map works, just look at a P5JS reference and explains exactly. It's just a linear transformation. That's all it is. You also need to reverse the y scale because the way the coordinate system works in P5JS is x values, as you go to the right, they get larger, but as you go down, the y values get larger. Probably you want it to be the other way. So high temperatures appear at the top and low temperatures appear at the bottom. So this line 73 just reverses the scale values. So high values appear at the top and low values appear at the bottom. Line 77 is another object oriented, another instantiation of a class to create an object. We're going to make a data column, which is just basically one data point, to hold the value that we scaled. By putting it in this object, we make it easy to draw and then we'll put the object in the data stream. And that way we tell the data stream to draw all the information it needs about what kind of variable it is, and that will already be there. And of course, having created this remember the y value came from way up here. We got a raw value from the table. We scaled it from Celsius to Fahrenheit. We mapped it to make a wider range. We flip the scale, and now we're going to put that value into an element of the graph. On line 80, that new element, temp DC, is added to the data stream. So that's going to actually make it available in an array of points so that when the graph is drawn, that point will be there along with all the others. One thing that's going to come up for you to do, we'll come back to this, is that you can do the same thing for humidity, rain, or wind, or all three. So you can actually have multiple lines all scrolling on your graph. Background 0 just erases the screen. The basic strategy here is like a lot of simple-minded animation. Every time we go through the draw method, we draw the entire graph, and then we erase it, and we draw it again, and we erase it, and we draw it again, each time adding a new data point on the left and throwing one data point off on the right. So that's what makes it scroll. That's not the most efficient way to do it, but it's the easiest way to do it. And background 0 just turns the canvas black again. If you want a different background color, just change that number. Line 90 is what actually causes the graph to draw. Having created a point, grabbed a point from the CSV file, scaled it, added it to a data column object so it's ready to go, added that to the data stream. All we have to do now is tell the data stream to render. And that will cause the data stream class, which we'll look at in a minute, to go through all of the data points that it has buffered up and draw them all in the display window. So that's kind of convenient because it means you don't have to do all that stuff out here in the draw method because it's contained inside this class. Then, of course, it's time to get the date time because that will come in handy for some of the things. Probably at some point, we want to somehow label the graph as far as what date we're looking at. And that's one of the tasks I've set for you. So we need to get that date time. And then we just log the date and time just so that we can check what's going on. So I'm going to run this now and show you what it looks like. And then we'll go back and look at a couple of the other classes that are being used. See the green line on the right-hand side in the preview window. That's a graph of the temperature. And notice when it reaches the right-hand side, the whole thing starts to scroll left. That's what the data stream does. The idea is you're looking at a window of 400 points out of 147,000. And each time we add a new point, we redraw the graph and slide it left 1 pixel. That gives you the impression of sliding across a long data stream, which is exactly what you're doing. Now, it doesn't have any labels, it doesn't have any scale, and we also have humidity and rain and wind that we can add to this graph to make it more interesting. But that's the idea. The magic happens, I'm going to stop it now. The magic happens here. If you look at data column, remember we put that scaled Y value in the data column, it ends up in here, and we just remember the name and the value in here. And data's column has a render method that's called, and that's what actually draws it. And this stroke color sets the color for a point. And this actually draws the point. Now, you could draw a different shape here. You can see commented on line 13 is a circle. There's no reason the graph has to consist of a series of single points. It could consist of a series of circles or squares or triangles, whatever you want. You'd have to change this code to do that, but it's easy to do. All of the data columns get collected together into a data stream. So this is actually a collection class. And the heart of the thing is an array right here, which in JavaScript is very much like a list in Python. It grows and shrinks as needed. You can add things on the tail end and you can pop things off the head end. And that lets us use this array once it fills up as a queue. And so what you're looking at when you watch the graph scroll across is you're looking at a queue being displayed. There's the add method. It just pushes the new value onto the end of the array, counts up, adds increments a number of points. If the array is full, meaning we've reached the full window size, it throws 1 point off the left-hand side and disposes of it, and just sets the number of points to the maximum number of points, 400. Every time it comes in there after that, all it's going to do is add the newest point to the right, throw the oldest point off the left. And of course, render just says, and this is a nice JavaScript, cryptic JavaScript idiom here, way of coding, that is a shortcut for a for loop that just goes through each element of that array, a stream array, and tells it to render itself, which is the proper object-oriented way of saying this. So you don't really have to understand these classes to use them. All you really have to understand is how they're used out here in sketch.js. And to add humidity to this, for instance, you can pretty much copy the code that's here, changing the variables and the variable names as appropriate, and creating a new data column for the humidity and a new data series to add it to. So that's one of the things you can do. Let's look for a second at the top of the program. And there's a list of things that, so I'm going to give you a pretty complete program. It does something, but you're going to enhance it to do a lot more. And that's what the assignment is. So here's some ideas for what you can add. And you can do some or all of these. Obviously, you can add humidity, rain, or wind, because we're just drawing temperature, but we know that CSV file has 3 more columns, which is the relative humidity in percent, the rain in, I think it's in millimeters, I don't know, and the wind speed. So those can easily be displayed probably in a different color or with a different kind of marker. You could add a marker for each day. As the graph scrolls by, we need to know where one day ends and the other day begins, maybe. That would make it more interpretable. And you could actually use a date and time to mark that in some way using text on your graph. Add a label for the y-axis. So it's actually got some numbers on it so we can see what's going on. Use some other marker. I think we mentioned this when we were looking at those classes. Some other marker like a circle, a rectangle, or a triangle instead of just a point for the graph. It'll make like a big fat line. Smooth the data using a moving average, which you saw how bumpy some of the data values were. If you smooth it, you'll get a much smoother curve. And to do that, you probably could just make yourself an array of, say, 5 values, average those 5 values, and put the average out each time. So that moving average sort of thing is very common sort of filtering or smoothing construction. You can Google how to do that, I'm sure. Use the temperature and humidity together to compute and graph the heat index. Sometimes on the Weather Channel, you'll hear them talking about the heat index. It combines the humidity and temperature. I sometimes call it the misery index. It combines the heat and humidity together to tell you how miserable you would feel. To attempt to quantify that. And you can get the formula from the reference on line 12 and see the complete equation for how they compute that. You could take for every point the humidity and the temperature, put them in the formula, get out a, I think I call it humiture value, and plot that on the graph. That might be interesting. You can also use the temperature and the wind speed to compute and graph the wind chill, which is refers to the fact that um, temperatures feel much colder when the wind is blowing strongly because they remove heat from your body more effectively. Use a symbol for each point. We mentioned that before, but make the size or color of that symbol indicate one of the other sample values. So maybe you plot the temperature, but you put the size of the symbols you use, say circles or squares, at each case depends on the temperature at that point. So you really would be packing two pieces of information onto the same data series. That's sort of interesting. Um, Set alarm points, like a low and high value, and display something on your graph when those values are exceeded. So if it goes below 40 or above 80, somehow make that visible. If you think about it, I'm sure there's some additional things you can think of to do here. So that's basically the project. You can clone this sketch to get started, which means you'll get the data. You don't have to upload anything. And you can start working on your copy to change the code in script.js, which is probably going to be enough for most of these exercises to, to meet some of these requirements. That's basically it for this exercise. In the last video, I'm going to talk about using these same data to um, audibilize the values to make sounds instead of a graph. Talk to you then.